Hi, good morning, everyone. I see some people are still logging in. Thanks for joining us this morning. Oh, courthouse bells ringing right now. Must be 10 o'clock here in Brown County. So good morning. I'm Laura Edwards. I'm the state climatologist with SDSU Extension out of Aberdeen, and I will be hosting the webinar today for Crop Hour. If it's your first time joining us, thanks for logging in. We do have two ways to interact with the speakers today. One is to use the Q&A function on your screen that will ask questions directly to the panelists. If you want to use the chat feature, you can do that and select panelists and attendees, and everyone in the meeting today, in the webinar today, will see your comments through the chat function. And we will try to address those probably more towards the end of each presenter today. It's a little easier that way, so we're not interrupting them. We also have Matt Knipling on with tech support for us, so if we have some logistical issues, he can help too. So today we have two presenters that will split the time. First, we'll have Dave Kringen, who's our water resources field specialist with extension in Mitchell Regional Center. And his title today is South Dakota Water Quality, Where to Find Information and What It Means. And then for those of you who are certified crop advisors, we will share that QR code for the first half here, for that first half credit at the end of Dave's talk before we go to the next presentation. I will share some information in the chat as we go along, including the YouTube channel where you can find the recordings and some other information as we go along through today for the next hour. With that, we'll start with Dave. And if you're ready to go, you can load up your talk, Dave.
Okay, thank you, Laura. Good morning, everybody, and happy St. Patrick's Day. I hope you're wearing your green today. I kind of forgot about it, but I do have a little bit of green here on my extension shirt, so we'll count that as good. So, and I hope wherever you are in South Dakota today that you receive some much needed moisture in our latest storm that came through on Sunday and Monday. So here in Mitchell, we got about 6 inches of snow, and it was heavy and it was wet and it was needed, and we appreciate that. So I'm going to go ahead and share my screen. Are we looking good?
You need to flip your view. Yep.
How's that?
Yep, there you go. You're ready to go.
Okay, so today we're going to chat a little bit about water quality in South Dakota and where you can go to find some information online. And it all starts essentially with the South Dakota Integrated Report. Every 2 years, the South Dakota Department of Environment and Natural Resources is responsible for assessing surface water quality within the state in order to meet certain requirements under the Clean Water Act. This information is reported to the US EPA in a document called the South Dakota Integrated Report for Surface Water Quality. And the intent of the report is to inform the citizens of South Dakota and the EPA of the condition of the state surface water resources, and to serve as a basis for management decisions by government and other entities for the protection of the surface water quality. South Dakota's latest report came out in 2020. So the next one will be 2022. DNR designates all surface waters in the state with one or more beneficial uses. And you can go through the list here, and you can see that there's 11 of them. And those uses get assigned a numeric criteria. for different water quality parameters such as nitrate, dissolved oxygen, bacteria, etc. Water quality standards were first established for all surface waters by the state's Committee on Water Pollution in 1967. And they were essentially federal standards that have been adopted by South Dakota. First one is domestic water supply. And here we've got a list of some of the different parameters that they look at. And probably of most talked about or of note is the nitrate parameter. So for any municipality or other entity such as a rural water system that provides drinking water to customers, the nitrate concentration must be under 10 parts per million. So what does 10 parts per million mean? Well, you can think of it as water in an eyedropper. So 1 part per million equals 1 drop of water into 10 gallons of water. So it takes approximately 1 million drops of water to fill 10 gallons. So 10 parts per million would essentially be 10 drops into 10 gallons. For cold and warm water fish life, you can see some of the different parameters, especially for cold water fish, dissolved oxygen, ammonia, suspended solids. Those are pretty important parameters. Immersion and limited contact recreation, they look at fecal coliform bacteria, E. coli, and dissolved oxygen. And all lakes in South Dakota are assigned these uses. So E. coli, if you're not necessarily familiar, it's a bacteria that normally is found in the lower intestine of warm-blooded organisms. Fecal coliform bacteria is a group of bacteria that are found in the lower intestine. Then we get to fish and wildlife propagation. Also, this is for stock watering, which is pretty important for livestock watering. You can see some of the things that they have concerns about for that. And lastly, irrigation in commerce and industry, conductivity, salts, those types of things are important for irrigation waters. So in the latest report, South Dakota has about 9,726 miles of perennial rivers and streams and about 87,780 miles of intermittent streams. And according to the 2020 integrated report, approximately 5,875 miles were assessed between October 2014 and September 2019. And during this 5-year interval, 22% of the assessed stream miles were found to support all assigned beneficial uses, while 78% did not support one or more beneficial uses. In addition to rivers and streams, South Dakota has 576 classified lakes and reservoirs, totaling approximately 213,265 acres. In the 2020 integrated report, contains assessments for 134,360 lake acres using water quality data collected from October 2009 through September 2019. And according to the 2020 IR, or integrated report, approximately 9% of the assessed lake acres were found to support their assigned beneficial use, while 91% did not. Causes for impairment in South Dakota rivers and streams. A high percentage of impairment can be attributed largely to high levels of total suspended solids and E. coli, as well as mercury in fish tissue. Total suspended solids can either be coming from crop ground or stream banks themselves. Causes of impairment for lakes and reservoirs. The primary causes for non-support are mercury in fish tissues and chlorophyll A. Mercury in fish tissue parameter, South Dakota was required to adopt that criterion of 0.3 milligrams per kilogram mercury in fish tissue a number of years ago. And those sources of mercury in fish tissue are mostly atmospheric deposition from sources outside of South Dakota. So it's a fairly new parameter, and it's really kind of lowered our approved designations since we've had it. Along with the numeric standards, South Dakota also has narrative water quality standards that are designed to protect beneficial uses of surface water from nutrient-related impacts. DENR has worked extensively with EPA to develop some chlorophyll A targets for lakes and nitrogen and phosphorus targets for rivers and streams. Chlorophyll A is it's a specific form of chlorophyll used in photosynthesis, and it's essentially a measure of primary productivity in a lake, essentially algae. So, for instance, a lake might be hitting its numeric criteria for immersion and limited contact recreation beneficial uses, but if it has summer-long algae blooms, then they would likely consider that to have a non-supported status. Anytime you probably go to Lake Mitchell or Lake Madison, you'll notice the algae there, and otherwise they may very well be hitting their other parameters. And these are done by ecoregions, and I just quickly circled some of the ecoregions that they use the criteria from. In that last slide, mentioned a few ecoregions. 42 is the Northwestern Glaciated Plains. 43 is the Northwestern Great Plains, which is mostly West River, consists of shale and sandstone. Ecoregion 46 would be the Northern Glaciated Plains, is a good chunk of East River. Those are the gently rolling landscapes composed of glacial till. And ecoregion 47 is the Western Corn Belt Plains, which is just in the southeast corner of the state. Well, how do I find out what the water's like? Well, now here in the past few years, DNR has come out with something called WQ Map, or Water Quality Monitoring Access Portal. It's an online hub for South Dakota water quality information. So before we had WQ Map, where did you go to get your information? Like if I wanted to find some information on the Big Sioux River, where would I go? Well, I could go to National Portal. I could maybe go to the city of Sioux Falls. Friends of the Big Sioux River might have some citizen science information. I could contact DENR and try and find some information there. East Dakota Water Development District regularly tests. And then other places on the DENR website, there might be some integrated reports, some total maximum daily load reports, different project reports or documents. But there was no real comprehensive source of water quality data and info specific to South Dakota. And what there was, it was not easily accessible to the public. So now we have WQ Map. And essentially, it pulls all of that information into one place. And this information I have here on this slide is a little dated, from December of 2018, but you can see that there's a lot of monitoring stations within South Dakota, and there's a lot of records in South Dakota. And some of those sources include DNR, different watershed projects, water development districts, geological survey, City of Sioux Falls, Friends of the Big Sioux River, and there's others too. But essentially, it all puts it in one spot. And this is where you go to start to find it. This is the front web page for South Dakota Department of Environment and Natural Resources. And I put that arrow up on the HTTPS. This is apparently a secure site. So if you were to get online and just type www.denr.sd.gov, it may not come up. So I found out that you need to type this HTTPS in there to get access to it. And then if you go down below, I've got data and mapping circled in the one-stop shops. And it'll take you to this page, which is the DENR searchable database page. This has got a whole bunch of information on it, but the one that we're going to look at today, the one I've got circled there, is the DENR Water Quality Monitoring Access Portal. And so once you click that, it comes up with this. And this will get you started. And it's essentially a map of South Dakota, and it will show you all of the monitoring stations that are involved with chemistry or citizen monitoring, or where they take fish samples. It also shows you all the status of the streams and lakes as far as whether they're supporting their designated uses or not. And you can start zooming in, you can move the map around, you can use the plus and minus buttons to zoom in or out. I'm originally from Flandreau, so I just, as an example, I went to Moody County and on the Big Sioux River, and if you click on the red on the Big Sioux River, it will bring up this little screenshot, and you can see, it's kind of hard to see, but you can look at the support status, the monitoring data, and other stuff regarding the Big Sioux. And if you click on support status, it'll show you the beneficial uses of that particular stream segment and whether they are being fully supported or not. You can also click and it'll show you all the monitoring stations within that particular unit. So there are different stream segments within the Big Sioux or any of the rivers. This particular one, I don't know where it starts or where it ends, but you know, it could start at Brookings County and end at some bridge, for instance. And that would be a stream segment. You can also click on a monitoring station. This one here I picked, I'm still in Moody County. And you can see, if you click on View Download Monitoring Data, it'll bring up this table and it'll show you all the water quality sampling that's gone on at that particular access point. You can see this goes back as far as 1999. So there's a lot of information here if you go through it, if you're interested in that. And then if you click on below, you can click access to all water body info. And that will give you information in a graph form, but it combines all the water quality data from those monitoring stations in that particular stream segment. So here I happen to look at total suspended solids, and those are the 4 or 5 monitoring stations within that stream segment are combined here. So it's kind of hard to show the capability of the water quality map without a live demonstration. But if you are at all interested in finding surface water quality data, for lakes and streams, I certainly encourage you to get online and just play with it and click all the buttons, because you can't break it. We also have, it's called the Statewide Groundwater Quality Monitoring Network. And here we show all the shallow aquifers that are in that the South Dakota Geological Survey Program monitors on a regular basis. There's 25 of them, and the red dots represent the monitoring stations. But I want to emphasize shallow aquifers on these. So the purpose of the network is to monitor present quality of shallow groundwater resources in the state and examine the short and long-term trends. And also they want to be representative of typical land use over the aquifer. So they won't put it near a point source or anything like that, so, or in the middle of a city. So operation of the network, it's sampled for common inorganics, including nitrate, ammonia, and phosphorus, and pesticides. And half the network is sampled each year, which I think they used to do them all every year, but due to budget constraints, they had to split them in half. So here's a typical well for a sampling site. They each have a dedicated pump in them to prevent cross-contamination. And also each site, most of them have 2 wells per site. And this allows the Geological Survey Program to sample the upper and lower parts of the aquifer, because some chemical constituents will stratify within a water table. Nitrate's a good example. So if you go to www.sdgs.usd.edu, you'll come up with this page. Apparently this is not a secure web page. But if you click online interactive maps, you'll come up with this. And this is very similar to the map I already showed you. It just shows you all the monitoring stations within the 25 shallow aquifers that they monitor. And similar to the WQ map, you can zoom in and out, you can move the map around. Again, I went to Moody County and I clicked on, you can click on the aquifer itself. And in the yellow, I just clicked on the aquifer and it will show you more info. You can click on that and it comes up with some information for you. It'll show you the locations of all the monitoring stations within the Big Sioux aquifer and information generated for that aquifer over the years. And again, just like WQ map, you can click on a monitoring station. Here I clicked one over by Flandreau in Moody County. And you can see that it'll give you some more information. You can click on that. And again, it'll give you a nice map of where the location of the monitoring station is at. And it'll also give you in graph form some of the different constituents that they look at. So most of these monitoring wells have been in since the mid-90s. So they're getting to be, 30 plus years or whatever of information. So if you have a well that you're drinking out of in some of these and some of these monitoring stations are near you, it might be of interest to look at some of this stuff on the Geological Survey website. Lastly, I wanted to talk a little bit about blue-green algae toxicity. This can be a problem for a lot of folks for livestock watering. Normally, they're not an issue, but under certain conditions, blooms can occur. If there's plenty of nutrients in the water, if you get some warm temperatures and not a lot of wind speeds that's circulating that water, you can get a bloom to occur. And they don't have to be green or blue-green. They can be bright green, they can be blue, they can be brown, they can be red. But they can, under certain conditions in certain species, produce neurotoxins and hepatotoxins in concentrations that can be dangerous to livestock and pets and people when exposed to it. Some of those signs include dizziness, difficult breathing, weakness, diarrhea, and sudden death. So my advice is, if you see a bloom present and you're not sure what it is, it's just best to assume that water could be dangerous if you're using it for livestock monitoring. So if you have access to other water, I'd certainly go ahead and use that, but monitor your ponds. And I tried to find some information on advisories or levels of neurotoxins for livestock, and they really don't have anything. I found some drinking water advisories and some swimming advisories, but I'm not necessarily aware of any for livestock consumption. It could be as similar to drinking water advisories, and plus livestock drink a lot more water than we do. So it doesn't take much. So like here for under the swimming advisory for microcystins, 8 micrograms per liter, which is 8 parts per billion. That would equal 8 drops of water in a 10,000 gallon swimming pool. So we're not talking very large amounts, and they can be dangerous. Here's some of the places, if folks have questions on what they have in their water, and if you see a livestock kill off, you want to test your water to see. Here's some different places to go to. Kansas State, our state vet lab sends a lot of folks down that way to the Kansas State Veterinary Diagnostic Lab. They will do both speciation and toxin detection. So they'll tell you what you have for algae in the water, or blue-green algae. They'll tell you what kinds, and they'll also test for toxins. North Dakota State University can tell you what kinds of algae you have in the water. And then specifically toxin detection, Midwest Laboratories is a private lab out of Omaha, Nebraska. Here's some different information on harmful algal blooms. DENR's got a nice website for that. It's got a lot of good information on there. Josh Strobel out of Pierre, he is their HABS coordinator. You can contact him with questions. But this has got some nice information on it. Of course, you can go to the United States EPA website, more general stuff, but there's a lot of content here. And then lastly, the North Central Region Water Network. I belong to a group called the Algal Bloom Action Team, and we're not more than a couple years old, but we are working on educational outreach material for a 12-state region. So a year or two ago, we all got together and we kind of combined everything. We brought, they asked the question, what do you have for algae bloom information? And South Dakota, we didn't have a lot. Other states like Ohio have a lot when they're dealing with Lake Erie. So we're working together, and we're hoping to come up with some good educational outreach material for folks. We'll also be doing research symposiums and every other month webinars. And I am the contact for South Dakota, and I'll try to get that information out as it gets developed. So I think that's the end of my slideshow. Yes, it is. And I'm right on time. So.
All right, great. Thanks, Dave. There was a question in the Q&A, but John addressed that for you. But if you have something to add, you can.
Okay.
Are there any other questions right now? You can post them in the Q&A for the panelists to see, or post them in the chat if you want everyone else to see them right away.
I always tell folks, if I don't necessarily know the answer, I know the people in the state that can get you the answer. So.
Matt has a poll to share for our first presentation today, and I will share screen as well with our QR code. This is the QR code for Dave's presentation. So if you're a certified crop advisor and need some credits here, this is half of a soil and water credit here today for Dave's talk. So Matt, I'll let you close the poll whenever you feel it's ready to go. Any other questions for Dave? Let's see, here you go, Dave. Mercury is atmospheric from outside of South Dakota. Where and from what source? Do you have that answer? You're working on it?
That's a good question. I don't necessarily have the answer right now, but you can certainly email me that question. I'll get you that answer.
Yeah, I don't know if John or anyone else on the panel knows the answer. I don't.
Yeah, so a lot of that is actually from industrial processes and coal-fired power plants.
Yeah, that's what I was thinking.
So.
All right. All right, I'll take the QR code down. Hopefully you all got that scanned there, and our poll is done. So next up, all right, thank you, Dave. Appreciate it. All right, next up we have Dr. John McMaine. He's our water resources specialist on campus in Brookings, and he is going to visit with us today about measuring nutrient loss. So John, I'll let you take it from here.
Perfect. Thank you so much. Just get my. All right, we seeing the right one?
Yep, you're good to go.
Perfect. Okay, well, thanks everybody. Thanks, Laura, for that introduction. Yes, I'm John McMaine. I'm a assistant professor and extension water management engineer in the agricultural and biosystems engineering department here at SDSU. And I've been in South Dakota about 3.5 years. So survived 3 winters, although it's the springs I've learned that really get you. You anticipate cold and snow in the winter, but then when you hit March and April, I'm used to, flowers popping through the ground. And while you get that, sometimes you also get quite a bit of the white fluffy stuff coming down from the sky. So that's taken some getting used to. But whenever I'm from Kentucky originally, and then from there I went to Oklahoma State. And when I was there and had gotten this job, and my title was water management engineer. And so my colleagues, they joked that, well, that's going to be 6 months of the year. And then the other 6 months is going to be snow management engineer. And unfortunately, that most of the years I've been here, we've at least had snow in 6 of the months of the year. So, but hey, I like the cold. I like the snow. I really like South Dakota a lot. So thankful to be here. So, I work with water management and water quality. And one of the biggest things, as Dave mentioned, the biggest concerns is nitrate, or that's a concern that's in the news quite a bit. And there's a couple of reasons for that, but in general, why do we care about nutrients? Nitrate is it's a nitrogen species, but nitrogen and phosphorus are kind of the two main ones that we care about when it comes to nutrients and water quality. And nutrients are, of course, critical from an agronomic perspective. They're essential. They're N, P, and K. It's the three macronutrients that we think about for crop growth. And so the reason we care about nutrient movement and nutrient loss is because that's an economic loss to producers. So at the field scale, the field level, that any nutrients that go downstream, that means that's money that is going downstream as well. And then it has a downstream treatment cost as well. And we'll talk about that for nitrate in the next slide. But nitrate has a drinking water standard of 10 parts per million, as Dave mentioned. And so any municipality or rural water district has to have a drinking water standard of below 10 parts per million for that water to go out to the distribution system and to be consumed by their customers. So that's it has a very defined cost. And then there's also environmental pollution. So it's a picture of Lake Mitchell. Dave also brought this up. And then up in the top right, I have a article about Lake Erie. And so Lake Erie, last couple of years, it has undergone some pretty significant algal blooms. And because of that, in one year, they actually had to shut down the Toledo water treatment plant because of those cyanotoxins that Dave mentioned. And so there's some real, defined concerns about water quality and infrastructure. And so there is potential for water or for environmental pollution when we think about nutrients. And all of those factors kind of come together that there is a potential for regulation. So that's why I want to talk about this today, that if we know how we can better manage nutrients, we can get out ahead of it, and we don't necessarily have to be told how to best manage nutrients on our farm. Because that's definitely not what I want. I don't know an individual's farming operation. I don't necessarily know what's best for that operation. And so I think the best approach is to be proactive and think about ways that we can improve each operation, in a way that fits the best, so we don't have to have regulation down the road. So some of these downstream costs that I mentioned, nitrate, drinking water standard of 10 parts per million or 10 milligrams per liter. And in Des Moines, and this was in the news quite a bit in the last 5 years or so, the raw water source that they had was over 10 parts per million. And so they had to treat that water to get it under 10 parts per million to be able to distribute it to their customers. And so that incurred a defined cost, about $8,000 a day. And they spent about $1.5 million in 2015 to treat this excess nitrate. And so the approach they took was they actually ended up suing 3 counties, 3 drainage districts upstream, and it went through the courts. And the court ruled basically that this was not a matter that could be decided by the judicial system. This needed to be something that was legislative. And so the problem hasn't necessarily gone away. With that lawsuit has gone away. And so this, in the back of my mind, as I think about nutrients, this is something I don't want to happen. And so again, I think it's important to be proactive, to think about downstream costs and any way we can minimize loss downstream. And so that's for nitrate. And then for phosphorus, so this is a picture from the 1970s. That's why it's such high quality. And this is a experiment that was supposed to be 5 years. And on the north side of the lake, they put in carbon and nitrogen. Then on the south side of the lake, they put in carbon, nitrogen, and phosphorus. Now, this is supposed to be 5 years. This is what the lake looked like after about 2 years. And so That was kind of a seminal research project that really helped us better understand that phosphorus typically is what we call the limiting nutrient for algal growth in freshwater systems. So basically the algae in the lake has everything it needs except for phosphorus. And once it gets that phosphorus, it can take off and bloom and grow. And if you think about it from a crop perspective, you could put on as much nitrogen or phosphorus or potassium, whatever you want. But if the crop is only going to grow to the lowest, to whatever the limiting factor is. So if you don't have enough of any nutrient, whether it's a macronutrient or a micronutrient, the crop can only grow to the level that limiting nutrient allows. So the same thing happens with algae. Typically, it has everything it needs except for phosphorus. So the phosphorus limits the amount that it can grow. But then once the phosphorus gets in there, it has everything it needs, so it really takes off. And the reason that this is an issue, other than kind of aesthetics and recreation and potential harmful algal blooms, this also, as the algae dies and decomposes, it also creates what we call a high biochemical oxygen demand, or BOD. So basically, that bacteria, as it's consuming that algae, it uses up oxygen. And so then it leads to anaerobic conditions, or conditions where there's no oxygen. And then that, has cascading effects for aquatic life. And so this is what has happened in the Gulf of Mexico. When we hear about the hypoxia zone, this is the situation there. And in that case, it's actually a nitrate issue because it's a marine system. Well, it's nitrate and phosphorus, but that's why we're concerned about nitrate in the big picture in the Gulf of Mexico. Now, the other thing that whenever I talk to individuals and they are thinking about, wanting to measure how much nitrate or phosphorus or whatever the case would be, they want to measure how much is coming out of their tile or whatever. And so the value that's usually given to me is a concentration. But I want to take some time and talk about how the mass, or the pounds of, we'll just say nitrate, the pounds of nitrate that are coming out of a tile, that's both concentration and flow rate. Okay, so we could have really in this scenario, all of these three scenarios are the same. We could have a high volume, the tile could be flowing full, but it could be a very low concentration. So we could take a measurement of that and say, we're probably okay because the concentration is very low. But think about the stream that's going into. So really it's about balance in the receiving body of water. So if that stream or lake or pond or river or dugout, whatever the case would be, if that maybe has a low volume, then whatever's coming into that stream could get overwhelmed by, or the stream could get overwhelmed by whatever's coming into it. So in any case, we could have high volume, low concentration, medium volume, medium concentration, low volume, high concentration, and all of these would roughly have the same load or mass or pounds of nitrate. And so the way we treat them is different for each one too. So if we have high volume, well, we can reduce the volume. If we have medium volume and medium concentration, we can reduce either the volume or the concentration. And if we have a low volume but a high concentration, well, then we want to focus on the concentration. And so, again, thinking about, when we take a water sample, get it analyzed, it's more than just concentration. We want to know the mass that's coming out of there, because once we know the mass, that actually enables us to look in our field and say, how much of what we applied are we losing downstream? So in very general terms, how much nitrogen are we talking about? And so I went actually on that same portal that David showed, the water quality portal, and went to USGS for the flow rate, got an average flow rate, Big Sioux River, Del Rapids, average concentration. And again, that's from that portal that Dave showed. And you run it through a bunch of unit conversions. You don't really need to worry about those. But basically you end up with, so we have a flow rate here times the concentration with a bunch of unit conversions, and it's about 5,000 pounds a day, or about 900 tons per year at that one location. So if you think about, you know, all the rivers in the state, all the lake, all the streams in the state, it could, you know, it could add up to be a pretty significant amount. But one word of caution is there is nitrate that is a background nitrate concentration, right? There's, you know, nitrate is part of the nitrogen cycle. It's part of, you know, life really depends on nitrogen. And so not all of that is because of human contribution. So, and by human contribution, you know, it could be point sources, it could be ethanol plants, or, you know, wastewater treatment plants, or water treatment plants, or lawns. Like, it could be any of these things, or it could be agriculture contributions. But it's, in this case, it's probably only about half of that total nitrate that's going downstream. So we expect some background concentration between 0.75 and 1 part per million probably. And so we would say 450 or so tons per year to maybe 600 are because of human introduction. So what about from a field? That's what we want to get to today, is think about how we can apply this to our field. And so again, this is just kind of average values for a drainage system with a 1/2 inch drainage coefficient. And then, you know, this would be really high flows in the spring, 750 gallons a minute. Like, this is really Kringen. This is a really big main. And then average concentration, that's, you know, I see ranges from anywhere from 5 parts per million up to 50. And so 20 is definitely in that range. And so that's about 180 pounds per day. And again, this is going to change throughout the year. Concentrations are going to change through the year. The flow rate's going to change through the year. But this is, you know, an example of a day, that an amount that could be lost in a day. So if we think of that back to, you know, what we applied on the field, then let's say we applied urea, 46 pounds of nitrogen per 100 pounds of urea, or 46% of the urea is nitrogen. And if we assume a cost of 40 cents a pound, then we could take that 180 pounds per day, and it'd be about $160 per day. Again, the drain flow will vary, the concentration will vary, but this still could be a significant loss. So why just, you know, take my word for it? This is something that you could do, and I would encourage you to look into. And so there's 2 methods you can do it. And so I'm showing you what we call the bucket method, but then I'm going to show you a better method. So bucket method, and this is to get flow rate. Basically, you go out there, you put your bucket under the tile, and you time it for 20 seconds or something, weigh that bucket, and then you have a mass flow rate. You have a mass that's come out per time, and then you can convert that to volumetric flow rate, or the volume that came out, by dividing by the density of water. So then you can get a flow rate that way. And again, the mass, or the loss, is concentration times flow rate. So then you take a sample, send it off, or there's nitrate testing strips you can use. You can get about 25 of those online for about $20. So you could use those throughout the year for, you know, pretty reasonable price. And then you can calculate your mass that you're losing. And again, this changes through the year, so I would encourage you to take, you know, multiple readings through the year. Now, I've gone out to a lot of tile in the last 2 years, and there's a lot of them that are not very far off the ground, or they're, you know, maybe they're going into a ditch, so it's hard to actually get down to the ditch to get a bucket down there. And so we've come up with a better method, which is where all you need is a ruler, and you plug it into this nutrient loss calculator that we developed. And so plug some different parameters into the calculator based on, what dimensions of your tile are, plug in your nutrient concentration, and then it kicks out a flow rate, nutrient loss, and then the value of that nutrient loss. So we'll run through this basically to measure slope. This is on grass. I understand it's not actually in a tile, but there's two ways you can do it. One would be to stick a level into the tile, and whenever that bubbles in the middle, it's level, then you measure the distance back into the tile. That's your run. And you measure the height that level is above the bottom of the tile. So that's your rise. So then you're just calculating slope, rise over run. So again, in this case, A would be the distance from the bottom of the tile to the bottom of the level. B would be the distance that the level is up into the tile. And then your slope is just rise over run. It's that A over B to get a slope. Now, they also have digital levels, which are pretty reasonably priced. And so we actually got a digital level and use that, and it works pretty well. Now, the second thing you need, and going back to the slope is something that's obviously not going to change, right? So once you measure slope once, that's not going to change. Now, the second thing is to measure the water depth. Now, the water depth is going to change. Of course, it's going to change through the year based on how much flow is coming out. And so you'll basically take a ruler, you'll put the narrow side in line with the flow, and you measure at the upstream end of the ruler. And so that's going to get your water depth. You collect a sample. This is the least streamlined part, because this is something that, you need to take a sample and refrigerate it or freeze it and then take it to the lab. Or again, you can use those nitrate testing strips. Now, the other thing to remember when we think about cost, so I had urea as the example up there, 46% nitrogen, that whatever type of fertilizer you apply is going to have different percentages of nitrogen. And this is important because if we get a nitrate concentration coming out of the tile and we know how much, what the cost of application was for various forms of nitrogen, well, then we can actually compare apples to apples, right? So if we're comparing all of the urea, so 100 pounds of urea at 40 cents a pound, really we want to see how much the nitrogen cost was in that urea. Same for nitrate. If we get a sample back and it gives us a concentration as nitrate, not as the nitrogen in that nitrate, then we need to adjust accordingly. Now, just a little bit of chemistry here, because I want to make sure that we understand this, what it means when we're talking about just the nitrogen in a molecule or in a compound. So nitrate, it's NO3, it's 1 part nitrogen to 3 parts oxygen, okay? So it's 1 part nitrogen plus 3 parts oxygen. And now the nitrogen and the oxygen, if we think about it on a molecular level, they weigh a little bit different amounts, okay? So to get the amount of nitrogen that's in a nitrate molecule, it's basically, it's the mass of the nitrogen over the total mass of that molecule. So that's what we have down here at the bottom. 1 mole or essentially 1 part nitrogen times how much it weighs, divided by the 1 part nitrogen times how much it weighs, plus the 3 parts oxygen times how much it weighs. And so that's how we get our percent nitrogen. That's how all of these other calculations for anhydrous or urea, that's how all those are done. So again, stepping through it, we want to get everything to the same. We want to get it to where we're comparing apples and apples. So if we send a sample off, we get a concentration back, we want to, it'll either be in the amount of nitrogen in the nitrate, it'll say nitrate nitrogen, or it'll say nitrate. Now, those are different because if it's just nitrate, then it's the amount of nitrogen in the water. It's a concentration of nitrate, the whole nitrate molecule in the water. If it's nitrate nitrogen, then it's the amount of nitrogen, it's the concentration of nitrogen that's held in the nitrate molecule in the water. So it's a little tricky to understand, but we just want to make sure that we're comparing the nitrogen part in whatever we're comparing across the board. So again, if we've gotten our concentration back and we've plugged that in, we've run it through our calculator, and then that's 180 pounds a day, for example, 46% of the urea is nitrogen, and it's 40 cents per pound of urea. So we're getting everything to pounds of nitrogen. So we're comparing apples to apples. So in summary, we want to think about nutrient loss because it does mean economic costs, both in the field and downstream. And we also care about it because if we get too much in natural systems, and that puts it out of balance. So for example, algae. But it's something we can measure, and it's something that we can adjust. We can adjust, infill practices based on what we're measuring out of our tile. Nobody else has to know what we're measuring out of our tile. We can use that as a management strategy. But then we can modify that management based on those results. Again, it's actually pretty easy to measure. Flow rate times concentration equals your mass, and you can use that nutrient loss calculator to do all that. But again, make sure you're comparing the same thing and can convert everything to nitrogen. So here's my contact information. I am on Twitter. If you want to follow me on Twitter, I've been super active lately, but feel free to shoot me an email or give me a call if you have any questions. And that's it for me.
All right, great. Thanks, John. If anybody has any questions, please throw them in the Q&A or the chat if you want everyone to see that. I don't see any questions right now. For those of you who are certified crop advisors, I'll share that QR code for you right now so you can scan that for your credits. And Matt will have a poll. We're just asking, some feedback from the presenters, so they have an idea how they're doing, and check in with you guys and see what you guys thought of today's presentation. And this is just for John's talk, this poll. The CEU scan, the QR code will not show in the recording, so please be sure to scan that now so you don't miss that. Any questions for John? I did put links in the chat for our YouTube channel where we have the recordings posted, and you can see any of those all the way back to January if you missed any of those. And also we have a form where you can request publications. So, since we're not seeing you all in person, we haven't been able to share, our pest management guides and some of our other, extension handouts and fact sheets that we've had, or little brochures. So if you're missing something or you want some more copies of something, go to that survey that's earlier up in the chat there for requesting those, and we'll mail those out to you. Sarah, I couldn't copy that link that you sent. I don't know if you can put that in the chat yourself, or there you go. Yep. So the link that Sarah just posted in the chat, that is for a survey for the end of the week to kind of look at everything water, weather, and climate related that we're talking about this week. We've had trouble sending that out on email. So if you guys have some feedback to give us or want to give us some feedback on the week overall, use that Question Pro survey there in the chat. Here in a little bit, we'll end the recording and open it up for open discussion. So stay on the line if you want to do that. I will stop sharing here for that QR code. I don't see any open questions, John. I don't know if you see anything on your end.
You know, we
All
were
right.
talking about coal-fired power plants as it relates to mercury. Is Big Stone closed? Or are they still generating electricity? I guess I'm not.
Oh, I think they're still running.
Are they still running? Okay.
I think so, yeah. Yep. Thanks everyone for attending today. We'll end the recording, and Matt, looks like you can move us all into Q&A if you want.